Hello, in today's video we're going to be discussing electron groups and how the number of electron groups surrounding a central atom in any given molecule will affect that molecular shape, that molecule's shape. So in order to identify how many electron groups are surrounding a central atom, we first need to understand what an electron group is. Now in chemistry there are 4 different types of electron groups, and I'm going to go through them now so then we can easily count them in any given molecule. So here we have single bond, double bond, triple bonds, and lone pairs or lone pair. And I want to go through what each one of these mean. A single bond in chemistry is represented by a single line. And each single line in chemistry represents 2 electrons being shared by 2 different atoms. Okay. So this single bond that's shown here has 2 electrons being shared. A double bond has 2 single lines, kind of looks like an equal sign. And each line here represents 2 electrons. So for a double bond, there's a total of 4 electrons that are being shared between 2 different atoms. A triple bond has 3 lines, 1, 2, 3, for a total of 6 electrons being shared between 2 different atoms. And then a lone pair is represented by 2 dots. Now, those 2 dots are not shared between 2 different atoms. They are actually placed on a single and particular atom and are found generally on the outside of molecules. So each one of these represents a single electron group. So if we have a single bond and a double bond, that represents 2 electron groups. If we have a single, double, and lone pair, that represents 3 electron groups. So based on the number of total electron groups that are present, it changes the structure of that molecule. Okay. So let's take a look at these 3 molecules that are here. We have carbon dioxide, boron tetrahydride, and boron trihydride, and carbon tetrahydride, or methane, down at the bottom. So let's take a look and count how many electron groups are present in each one of these. Well, when we're looking at a molecule, we're only looking at the central atom for counting the total number of electron groups. So here we have oxygens and carbons. The oxygens are not the central atom, so we don't care about their electron groups of these lone pairs. We're only looking at the shared electrons or the lone pairs on the central atom. So here we're going to be looking at the carbon. It has a double bond on its left, it has a double bond on its right. Each double bond represents 1 electron group, so this has 2 electron groups. Boron Try Hydride, on the other hand, has 3 single bonds. Each single bond is an electron group, so this has 3 electron groups. And carbon tetrahydride, also known as methane, has 4 electron groups. It has 4 single bonds, 1, 2, 3, 4, so it has 4 electron groups. Now, based on the number of electron groups, that is going to affect how this molecule is shaped. And the reason for that, let's go back up to this carbon dioxide up at the top. The reason why the molecular shape is a function of those electron groups is because each electron group has a certain number of electrons present within it. And we know that particles of the same charge repel each other. Just like with magnets, South Pole and South Pole repel each other, North Pole and North Pole repel each other. Every electron group is repelled by every other electron group. So if we look at this structure up here, the CO2, carbon dioxide up at the top, we see that it has an electron group on the left, electron group on the right. They are repelled by each other. And the absolute furthest away that you can get if you have 2 groups surrounding a central atom is a bond angle of 180 degrees. So since these are both as far apart as they can be from each other, 180 degrees, we call this structure linear. It kind of makes sense, it looks like a line, so it's a linear structure. These down here are a little bit more tricky. A boron trihydride has 3 electron groups. It's called a trigonal planar molecule. And in class tomorrow, I'm going to ask you what bond angle should go between these 2 hydrogens. Now, I'm not going to tell you what the answer is in the video, but I want you to go home and think about it and then come to class with an idea of what that bond angle should be. Okay? So this is trigonal planar. This down here, this methane, is tetrahedral. And also, I want you to tell me what the bond angle is between those 2 hydrogens. I'm not going to tell you in the video again. You're going to have to go home and you're going to have to practice and try and figure out what bond angle you think it should be there. Now, I'm going to give you a hint to help you out with this. Everything that I've drawn up on the board is a 2-dimensional representation of a 3-dimensional system. So even though I drew this in a very specific way up at the board, it may not be the best possible way to draw a three-dimensional system on 2 dimensions. So what you need to do is you need to take these molecules in your mind and rearrange them in 3-dimensional space and try and get those electron groups as far away from each other as possible. Some of these that I wrote up here are pretty accurate in the way that they look, some are not. So go home, practice with this, try and figure out how far apart you can make these electron groups. We'll come back tomorrow, we'll do a whole lot of practice, and then we'll move on to some more advanced organic chemistry. So with that, I want to say have a great night, and I'll see you all in class tomorrow.